Hi everyone. In the previous class, we have seen how to find out the Laplace transform for any function like Laplace transform of f of t. This function can be replaced with the corresponding function equation. What is the Laplace transform of f of t for the one-sided functions? Integral 0 to infinity f of t into e power minus st into dt. This function f of t can be replaced with the corresponding function equation. By that, we'll get the Laplace transform. So let us take, this is the type of the function. We'll see what is a function, a represent mathematical representation, and what is, when you apply the Laplace transform, how it will be transformed from the time domain to S domain. So here f of t is nothing but f of t is converting, when you are applying the Laplace transform, f of t can become f of s, time domain to S domain. So let us take impulse function. Impulse function, a representation is del of t. Del of t, when you apply the Laplace transform to the unit impulse function, you'll get 1. That's what we've seen with the derivation also in the previous class. So what is a step function? Step function u of t. Unit step function is nothing but u of t is equal to 1. If you substitute u of t is equal to 1 or f of t is equal to 1, you'll get 1 by s as a f of s. A ramp function, time domain representation is t, and if you convert that into the s domain by applying the Laplace transform, it will become 1 by s square. Exponential e power minus at, s domain is nothing but 1 by s plus a. Sine in time domain, sine omega t. In s domain, by applying the Laplace transform, you'll get omega by s square plus omega square. We have seen the derivation. In a similar way, you can find out all the functions by using the same derivation in the previous class. Cosine representation in the time domain, cos omega t. If you apply the Laplace transform, you will get s by s square plus omega square. Hyperbolic sine, sine hat. So which can be, if you apply the Laplace transform, you will get a by s square minus a square. Hyperbolic cosine, cos hat. By applying the Laplace transform, you will get s by s square minus a square. Damped ramp, t into e power minus at. If you apply the Laplace transform, 1 by s plus a square. E power minus at is nothing but 1 by s plus a. When you are multiplying with t, you will get 1 by s plus a square. Damped sine waveform, e power minus at into sine omega t. So generally, if t is nothing but 1 by s, right? If you are multiplying t with the e power minus at, you will get the 1 by s plus a square. In a similar way, sine omega t is nothing but omega by s square plus omega square. Sine omega t is nothing but omega by s square plus omega square. When you are multiplying with the time domain, e power minus at shift, it will become omega by s plus a square plus omega square. Damped cosine, e power minus at into cos omega t. For cos omega t, s by s square plus omega square. If you are multiplying with e power minus at, there is a shift in the s domain also, that is s plus a by s plus a square into omega square. Wherever s is there, that need to be replaced with the s plus a when you are multiplying with the e power minus at anywhere. So this is all about the list of Laplace transform pairs. In a similar way, if you see the list of operational transforms, so what kind of operation will do it, and what is the function f of t in time domain, how it be converted into the s domain. So multiplication by a constant, when you are having f of t, if you are multiplying with k in time domain, it will become k into f of s. F of t is nothing but f of s, the same k will be multiplied in s domain also. Addition or subtraction means, in time domain, if you are adding or subtracting the two functions, the same functions can be added or subtracted in s domain also. First derivative in time domain, differentiation of f of t by t dt, df of t by dt. If you are differentiating in the time domain, in s domain it will become s into f of s minus f of 0. Laplace transform of d into f of t by dt will become s into f of s minus f of 0. So this will use during that individual elements are in the circuit analysis, Laplace transform circuit analysis. During the inductor and capacitor, it will also have like L into di by dt, C into dv by dt, I is equal to C into dy by dt, or V is equal to L into di by dt for the inductor. During that time, if you are derivating, means if you do the Laplace transform of that corresponding function is nothing but L into di by dt, means L into I of s minus I of 0. Like that we can get it. Okay. So the second derivative of time, d square f of t by dt square. Laplace transform of d square f of t by dt square is nothing but s square f of s minus s f of 0 minus d f of 0 by dt. Earlier we have only one derivative, means sf of s minus f of 0. If you have two derivative, means s square f of s minus again s into f of 0, again one more differentiation d by dt of f of 0. Time integral means integral 0 to t f of t into dt, f of s by s you'll get in the s domain. So time integral is nothing but 1 by s. Okay. Derivation means s. Derivative means yes, you'll get it. And integral means 1 by s, you'll get it. Translation in time. If shift occurs with a time, f of t minus a into u of t minus a, where a is greater than 0, means in the s domain, the same shift can be represented with my e power minus as. F of t minus a, that is represented with the unit step function, into u of t minus a. This shift can be represented with e power minus a into f of s. Translation in frequency, e power minus at into f of t. If that e power minus at comes in the time domain, then in s domain it will become f of s plus a. Already we have seen damped sine, damped cosine, damped ramp. If e power minus at comes, earlier only t means 1 by s. E power minus at comes means 1 by s plus a, means f of s plus a, right? Wherever s is there, that is replaced with the s plus a. That's what. Wherever you are having the s, that can be replaced with s plus a. Scale changing, if you are multiplying with the a, f of at, it will become 1 by a into f of s by. That means wherever f of s is there, that can be replaced with the s by a, and that need to be multiplied with the 1 by 8 outside. First derivative, t into f of t. T into f of t can be written as in s domain minus d into f of s by ds. So this is all about the operational transforms from time domain to s domain. Thank you all.